All right, the next thing that we're going to do is put together high scores. So that's going to require us to put together a high score manager, which will allow us to add high scores to our game. It'll also require us to put together a high score screen, as well as allow the user to put in a name at the end screen of the game. Now, what I'm also going to do is I'm going to modify our level managers so that when a user completes a level, points will be awarded depending on how much time was left in that level. So that way we don't have to worry about keeping track of the time and the points at this, simultaneously, and we can kind of merge them together so that they get some sort of bonus for completing the level quicker. But we don't want to make that bonus too high because we still want the users to feel compelled to shoot asteroids on their way between waypoints. So I'm going to go into Level Manager, and this is going to be a very simple change. I'm simply going to say if they hit a waypoint and the next waypoint is null, that means we know that they're at the last waypoint in the level. So I can simply say game manager instance.points plus equals time left multiplied by some sort of modifier. Let's say we want to give them, how about 10 points per seconds for the amount of seconds that they have left. Now you notice that we have this line squigglified because we are trying to convert time left being a float into an integer, which is what the points property is. It's easy to fix. I am going to use cast to int in addition to math.ceiling on time left. And the reason I have to do both is that a cast to int will truncate the decimal place. However, I want to round the time up to the nearest second, so that's why I'm doing math.ceiling. But unfortunately, math.ceiling returns a float, so I still have to do that integer conversion. So now that I've done that, let's go ahead and put together a high score manager. That's just going to be a really straightforward singleton class that's responsible for keeping our high scores inside of the player prefs component in Unity. Now, player prefs will store that information somewhere on your local computer. I'm also going to write a high score class, and the high score class will simply be a DTO or data transfer object that contains the name of the player as well as the points they received. So let's do the high score class first. Now, high score is simply going to be a string name with a int points. Now, I'm going to have both of these be set to automatic properties, which will have a public getter and a private setter. So that way, the only way to set these values is to pass them through the constructor. So once I have this basic class put together with these two automatic properties with private setters, I'm going to go ahead and put together the high score manager. So I'm going to add another class. It's going to be called high score manager, and it will be a singleton class. That means that there will only ever be one instance of the high score manager instantiated in the game, and that instance will be available through the instance property that we're going to write. So let's go ahead and signify it first. To do that, I'm going to have to write a public static high score manager instance property. Now, this can't be an automatic property because I'm going to have to make it so that the first time this property is accessed through the getter, it will instantiate a new high score manager, which means I also need somewhere to store that single instance. So in addition to the public static property, I'm going to need a private static high score manager instance, or sorry, I have an underscore instance for our where we're going to store the instance of the high score manager. Now, actually, I'm just going to do underscore lowercase because that's how I have my convention set up in ReSharper. So the getter to this property will simply say if instance is null, then instance equals new high score manager. Finally, return instance. I could turn this into a single expression using the null coalescence operator, but for the sake of clarity, I'll leave it this way. Okay, so this is our high score manager. We need to do one more thing to turn it into a singleton, and that is to come up with a way to prevent it from being instantiated from outside of our instance property. It's actually very easy to do. We simply have to create a constructor that is private. A private constructor will prevent this object from being instantiated anywhere outside of this class. Now you might be saying, why would you ever want to do that? And the answer is, well, this. But by marking a constructor as a private, we are preventing it from being instantiated anywhere outside of the class, which we're doing here because we're only instantiating it inside of the instance property.
Sweet.
Okay, so now we need a couple more things. A couple more bits of data. I want to specify a constant value that will determine how many max score or high scores there are going to be. So I'll say private const int max high scores equals 10. So there'll be a total of 10 max scores in the game. Next up, we need a way to store the max scores. So I'm going to write a private read-only list of high score called scores. Now this is going to necessitate or require us to import the systems collections generic namespace. So by clicking that button, we get a using system collections generic up at the top. Finally, as far as data is concerned, we also need to write a public IEnumerable of high score scores property with a simple getter that will return scores. Now, the reason I am writing this property as an IEnumerable of high score and not a list of high score is because a list of high score is an IEnumerable of high score. But by exposing this property through the IEnumerable type, we prevent any object from outside of the high score manager to be able to edit this data. We want to encapsulate this data in its entirety. This will allow us to retrieve the scores, but it won't allow anybody outside of this class to edit those scores. So the data is properly encapsulated.
Very nice.
Okay, so we have to finish our constructor, and we're going to write 3 methods. Now the constructor is simply going to retrieve all of the current scores out of the player prefs. So I'm going to say scores equals new list of high scores. That's the first thing I need to do. Then I'm going to say for var I equals 0, I smaller than max high scores I++, which will create a loop that loops max high scores times, which in this case is 10. I'm going to try to retrieve the max score from the player prefs component. So what I'm going to do is I'm going to say var name equals player prefs dot get string. I'm going to say high score underscore curly 0 underscore name. And there are a couple things we need to do. We first need to import Unity Engine. So clicking that will import Unity Engine with the using statement at the top. The next thing we do is I need to surround this with the string format because we're using a format string pattern to insert the I into the middle of that string. So now the I will be replaced with that little 0, and we have a string that represents the key into our player prefs component. Now player prefs will return a default value if this pref wasn't found. So I'm going to override the default value with null. That means that this getString method will return null if there is no high score name at the specified index. Using that information, I can say if name is null, we're going to break. So if name is null, we're going to exit the loop because there is no high score at I. But now that we know that there is a high score at I, we can say score equals player prefs dot get int high score, curly 0, score, surround with string format, and we now have a score retrieved out of our player prefs. I'm not going to worry about the default here because because if we got to this point, that means we already retrieved a name out of the player prefs at this index, so we'll just assume that a score was brought along for the ride. Of course, we haven't written any code to save this information yet. We're just writing the retrieval code first, but we'll get to that here shortly. Now that we have the name and the score in a variable in this loop, I can simply say underscore scores.add new high score name score. At the end of this...
Nothing, just really awesome.
Sweet. So at the end of this loop, we have loaded all of our scores. Now there are going to be 2 public methods on this class. The first one is going to be public bool can add high score endpoints. The can add high score will return true if we can add points to the high score, or if we can add a high score that has this many points in it. We determine that by two checks. So there are two conditions we have to watch out for. A, if the scores count is smaller than the max high scores, return true. For example, if we only have 4 high scores in our system and our max high scores is set to 10, that means that regardless of the points that were achieved during a playthrough, that does indeed constitute a high score, and we should ask the user for their name. Next, if this is not true, then we'll simply say scores at max high scores minus 1 dot points is smaller than points. The second check says that, okay, so if our scores are already all filled up, we need to see if the last high score is smaller than the score that we're trying to add. If it is, return true. If it's not, return false. Okay, there's one more public method that we have to write on our high score manager, and that's going to be public void add high score with name and points. Now, this is going to be the most complicated method here, but it really only boils down to 3 steps. The first step is saying, if not can add high score points, throw new invalid operation exception. If the user didn't, or if the client of this class didn't check to see if we could add a high score in the first place, and then tried to add a high score, we're just going to throw an error and say, you know, you should fix this bug because this is probably a bug in your code and not in the high score manager. So we'll inform that to the developer through the use of an exception. Now, the 2 other steps that we have to do is we need to determine where to insert the high score into our list. Then we need to, the next step will be to trim the high score list to be only max scores length. So to determine the index we need to add the high score into, I'm going to simply say var insert index equals scores dot find index, which takes in a predicate, which is a delegate, which I'm going to satisfy with a lambda. I'm going to say score points minus less than points. So this reads scores dot find index, score goes into score dot points is smaller than points. What this will return is this will return one of 2 things. It'll return a -1, or it'll return an index in the list where we should insert our new high score. If it returns -1, that means this predicate was unable to identify a high score that had fewer points than the high score that we're adding. That means we should add the score to the end of the list. If it does return an index, however, that means that we need to insert the high score at that location. We can do this in a single line of code. I can say scores dot insert. Then, for the index parameter, I'm going to say if insert index is -1, then return scores dot count, otherwise return insert index. So we're using a simple ternary here. We're saying if insert index returned -1, which means it wasn't able to find a score that was less than the score we're adding, add it to the end of the list. Otherwise, add it to where it told us to add it to. The second parameter to insert is the actual object we need to insert, which is simply going to be a new high score, passing in name and points into the constructor. The final step that we need to do in this method is going to be to trim our high scores. And that's because if we do insert something that isn't at the ends of the list, we need to make sure to trim off that last item that was added. So we can simply say var to remove equals scores.count minus max scores. Max high scores. If to remove is greater than 0, we'll say scores.remove range from max scores to remove. So this, or max high scores. Why do I keep on doing max scores? So what this will do is this will trim our array or our list so that there are only max high score items in it. Okay, so I said that that's the final thing we need to do inside of this method, but I kind of sort of lied about that. What we're going to do is we're going to write another method that will be invoked from add high score that will actually go out and save our high scores back into our player prefs. So that's going to be very easy to do. We're simply going to say save high scores. So that's a method I haven't written yet, and it will be a private method. So we'll simply say private void save high scores. Save high scores will simply go for var I equals 0, I smaller than scores count I plus plus. Then we're just going to say var score equals scores at I. Then I'm going to say player prefs dot set string high score curly 0 name. Be sure to surround this in a string dot format, passing in I as the parameter. Then comma, the value is going to be score dot name. Now you'll see that this data right here corresponds to what we're expecting to retrieve out of it in the constructor. So that's all good.
Making sense now?
Yep. And then we do the same thing with the scores. So we'll say player prefs dot set int high score at 0 score, which I believe is what I did up there. Yep, I did. And then surround this with the string format, pass in I as the argument, and then add in score dot points.
Very smooth.
Sweet. So now we have a high score manager, and it's completely self-contained. So we can now use this class from any point within our application because it is indeed a singleton. So where do we need to use this? Well, the first place I'm going to use this is on the end screen. So let's go down to our end screen. And on the onGUI, what I'm going to do is I'm going to say if highscoremanager.instance.canAddHighScore game manager instance.instance.points. So if we can add a high score, then say GUI layout label, you got a high score, enter your name. Then I'll say, then I'll invoke the GUI layout.text field to retrieve the name from the user. However, to do that, to use a text field inside of Unity, we need to make sure that we have a private string up at the top as in the form of a field of the name of the user. So I'll simply say private string underscore name. I'll initialize this to empty string because if we leave it as null, the GUI layout methods will break. So to present the user with a text box, we simply say name equals GUI layout dot text field underscore name. And that'll present that to the user. Then I want to present them with another button. I want to say if GUI layout dot button add score or save score, then I'll say high score manager dot instance dot add high score, passing in our name and our game manager instance dot points. Now, the final thing I want to do is I want to make sure this button disappears once we save the score. So to do that, I need one more bit of data on our end screen mono behavior, and that is going to be private bool has added score. Now, Booleans default to false, so that's what I want. Once we hit the button, I'm going to say has added score is now true. Then, to make this entire thing disappear, I'm going to say if not has added score, then present them with this form. Otherwise say GUI layout label score added.
You have 3 Ds in there.
Added. Okay, so that's if we can add a high score, it'll give us a button. Otherwise, I want to say GUI layout dot label you didn't get a high score. Frowny face.
Of course.
Yep. Okay, so I'm going to leave it like this because I want to have a alternate screen to display the high scores. You could certainly display the current high scores from within this onGUI if you wish. So let's go ahead and see if this form even works first, and then we'll add our high scores form in to another screen. So jumping back into Unity, I'm going to jump all the way into our scenes, screens, start screen, and I'm going to hit play. I'm going to hit start game, and then I'm going to win, and it's saying you got a high score with 280 points. I'm going to put in my name as Nelson. I'm going to say save score, and it says score added. Let's do that again. I'm going to hit close. I'm going to hit start game. And then I'm going to shoot some asteroids so I get some more points than I did before. So shoot some of those guys. Oh, well, and then I lost. So I still only got 250 points. Or 450 points. Let's just say whoa. And save score. Score added. And then why not add one more score? It's just going to be the same because I'm just going to fly through all of these guys so I get to the end screen. And blah. Save score. Score added. Close. Okay, so in theory, we just added a bunch of scores to our player press. So now let's go ahead and add in the high score screen. So I'm going to jump into Visual Studio and reload, of course. I'm going to create the new mono behavior for my high score screen, or at least stub it out. Go back into Unity, create the scene, or the screen scene, and then finish the implementation for my high score screen. So I'm going to add in a new file, and I'm going to call it high score screen. Not surprisingly, very uninspired but fairly self-evident name. And I'm going to have it inherit from mono behavior. So this is my high score screen. I'm not going to fill out the implementation yet. I'm going to jump back into Unity. I'm going to go to File, New Scene. I'm going to hit Control S to save the scene. Then I'm going to go into my Scenes folder, my Screens folder, and then I'm going to give it a name of High Score Screen. Hit Save. Then, of course, I'm going to remember to go to File, Build Settings, Add Current, and for just organization purposes, I'm just going to float this guy all the way up to the top near Start Screen. It would just bug me if, I don't know. Like, it doesn't matter at all. It doesn't make any difference because we're not using the scene indices to do anything, but I just like it like that.
It's just one of those OCD things.
Yeah. It just makes more logical sense to me. Okay, so that's our high score screen. It's added. Now let's go into our code folder, and I'm going to click and drag high score screen onto my main camera. So now I have that script attached to my main camera. So what I'm going to do now is I'm going to jump back into Visual Studio and I will implement my high score screen. So to implement it, I'm just going to go public void on GUI, and then I'm going to say var scores equals highscoremanager.instance.scores. Then I'm going to say GUI layout.begin vertical and match it up with the GUI layout.end vertical. And in between these two things, I'm going to say for each var score in scores, I'm going to say GUI layout.begin horizontal, match it up with the corresponding GUI layout.end horizontal. And then I'm going to say GUI layout.label score.name, and I'm going to say plus colon. Alternatively, we could use format string for that as well. And then I'm going to say GUI layout.label with blank points, score.points. Finally, outside of the for each loop, but before the end vertical, I'm going to say if GUI layout.button.back, or back, then application.load_level start screen. Now, I'm going to go ahead and jump into my start screen behavior and add in the logic to switch to the high score screen if they press a button on the start screen, just because I happen to be in Visual Studio at the moment, and this will only take a second. So jumping down into my start screen, I'm going to say if GUI layout.button high scores, then application.load_level high score screen. Okay, jumping back into Unity, I should be able to now load up my start screen, so I'm going to double click on that scene and hit play, and I now have a high scores button. And if I click on it, I get this. Now you'll notice that we still have a bunch of blank items, so we're still loading up all those blank items for some random reason. So let's go ahead and figure that out. I think I know why. Yeah, I'm pretty sure I know why. I do believe that my player pref's getString method is ignoring my default value and simply returning an empty string anyway, even if I told it to return null instead of an empty string, so I can detect if this string existed inside of my player prefs. So to change this behavior, I'm simply going to remove the default value as it's not doing anything, and instead of comparing name with null, I'll compare name with empty string, which is empty string is simply two double quotes without anything inside of it.
Alrighty, cool.
Jumping back into Unity, we can hit play, go to high scores, and now we have Woe, Nelson, and Blah.
I'm glad it actually was cool. I was going to be sad if I said that and it was still there. Good job.
Okay, let's go ahead and try to get a higher score. I'm going to completely ignore the gates. And yep, I got a way higher score. So I will type in a name of should be first, save score, score added. I'm going to close out of the you lost screen, go back to high scores, and should be first is indeed first.
But didn't they lose?
Yes, but they still acquired points. That is a decision that you guys can make. I'm kind of doing that here for purposes of demonstration because it would be kind of impossible for me to win with the way I have the waypoint set up with getting variable scores.
Gotcha.
If you wanted to change that behavior, you're more than welcome to. Really, the only thing you would need to do is go into end screen and not display this form if they lost.
Gotcha.
So,
cool.
Either way you want to do it. I think that pretty much wraps up all of our logic for the game as far as game mechanics go. The last things we have to do with polishing it up, adding some effects and some sounds, and fixing up our menus a little bit. So let's go ahead and get started on those.
Cool.